Hi everyone, thank you for joining us today. We're here at Ubisoft and we're going to tell you some things about our Snowdrop engine. So without further ado, let's get this started. So a few words about ourselves. My name is Andreea. I am a senior gameplay programmer at Ubisoft, and in the past 8 years, I've worked on projects like Watch Dogs, Watch Dogs 2, Watch Dogs Legion, and I'm currently on The Division 2.
And my name is Liviu. I'm a level design director at Ubisoft Bucharest. I spent most of my career in the level design field and creating worlds with IPs like Assassin's Creed and Watch Dogs. A bit about our agenda today. So we're going to talk about what is the Snowdrop engine, what was the philosophy behind its creation, the node graph system that is powering this engine, the way it's impacting our users, and of course, what we envision the future of Snowdrop to be. So first of all, what is a game engine? A game engine is a software framework that is being used by developers to create their games. It includes relevant software, code libraries, tools, and support programs. If you will, it's what is under the hood of any game. Snowdrop then is our game engine. It was created by the Ubisoft Massive Studio during the development process for the first Division title. It includes an arsenal of tools that helps developers create their content and create an awesome game. Over time, it's evolved and was used for other games like Starlink Battle for Atlas, the South Park franchise, Mario and Rabbids, the Settlers, and of course, the second Division title. So let's talk a bit about the philosophy behind Snowdrop. When development of this engine started, the team was in a very good position to start from scratch. From previous experiences, they knew that they wanted to focus on one thing, which was to have tools to unleash the team's creativity, tools that are precise, easy, and fun to use. For us, happy users means awesome content. So to this extent, they defined the core pillars of what would become the Snowdrop engine. The most important one is called what you see is what you get, which means the engine provides instant feedback as much as possible throughout all the tools, and the users can trust that what they see in the editor, it's what they're going to have when the game is running. Modularity of the tools is another important aspect. Snowdrop comes with a number of tools, and each of them can function on its own. This enables the teams to work with flexibility, with specific modules for their part in the development process, without necessarily getting involved with other tools if they don't have to. The next one is productivity. This means fast iteration times, so making sure developers can quickly see how their work looks like in game, and being able to enter the game directly from the editor. Snowdrop supports hot reload for changes done inside its various tools, so the users can see how their changes impacted their work as soon as they save them. At its core, Snowdrop is a node-based system, so it allows developers to prototype and test things without investing unneeded energy on something that they would potentially discard. So they can prototype their ideas really fast without the need for extra programming time. Snowdrop's user interface system also relies on the node graphs. It comes with a vast library of useful nodes, widgets, and compounds that let developers quickly set up their 2D or 3D interfaces. UI is tightly connected to almost every aspect of the engine. Finally, Snowdrop is all about allowing content creators to focus on their work. Assets are easily accessed and created using the unique content browser. Artists and animators can use almost any tool to create, modify, and refine their work and import it into Snowdrop. A few more words on assets. So multiple systems in the engine are based on node graphs. which allow easy communication between assets. So this means that when creating an asset, the inputs that the users are targeting can propagate through other systems. So, for example, here we have a van that's being shown inside the level editor, and we have various parameters exposed, like the color. When we open the object editor, we'll notice that van color is an input node, which is passed on from the level editor, and which will be further passed down the line to the shader editor, which also makes use of this information. Now, for more details, Andrea will give us more information on this powerful node graph system.
So, as Liviu was mentioning, we're building our assets using node graphs, which are edited by our content creators. And I'm going to go a bit into detail on how these node graph systems work in Snowdrop. So if you're not familiar with node editors, they're basically a visual representation of game logic and flow. And programmers expose the nodes from code, which content creators then link together inside node graphs. So one of the most important things for our node editors is to expose atomic functions. Most of the node editors that we encounter today have more high-level functions exposed, whereas we're thinking a bit more lower level, like even arithmetic or logical operations, comparisons, but also entity-specific functions. Nodes can support various data types, ranging from basic data types like ints or floats to even more complex types that have custom behaviors and editors associated, like, for instance, a color gradient. Our node system editor system also supports the definition of variables. So we have constant variables, local and global ones, which can be used in nodes that affect the flow of execution, like branching or looping nodes. So with the node graph system providing these functionalities, we're basically exposing the building blocks of the engine, and content creators have the chance to combine these nodes and create the higher level functionality themselves without having to go to a programmer for help. Another useful feature of the node graph system are compound nodes. So compound nodes are basically the possibility to embed a node graph, making it reusable. This way, content creators don't have to duplicate functionality. They can just create a compound node and reuse it wherever necessary, much like a programmer would create a function in code. And here you can see some examples of existing compound nodes, like randomizing the value by range or getting the relative angle between entities. And a great advantage of this feature is that if needed, these compound nodes can be easily replaced with code without affecting the feature development workflow. So until then, content creators can build the complex systems that they need without involving a program. So with the building blocks of the engine, along with advanced functionality of the compound nodes, content creators can start building game assets, and the possibilities grow exponentially. In the previous slide, you've seen the object editor and the shader editor, but Snowdrop has many other systems that use node graphs, and adding a new node system around one node editor could benefit all others. For instance, the compound nodes that we've just mentioned are one of the systems that can be used in any of the node editors available. We also have group nodes, which allow users to group nodes together and reduce visual clutter. And we also have comments that can be added inside the node editors to provide more information on the implementation. The node variables are another system that is also shared. And we also have a node editor timeline where content creators can set curves and have a more time-based approach, which is sometimes necessary. So many other systems can be added, and the great thing is that they will benefit all node editors from Snowdrop. So moving forward, let me tell you a bit about how Snowdrop's node editors are being used from the low-level functions to the higher-level ones. As an input, we have all of the things that are created by the artists. We have the source assets, textures, animations, models, sound, and those are used by our node systems. Here are some of the node systems that you might already be familiar with. You might have seen, for example, node-based animation systems or visual shader editors. In Snowdrop, we also have particle and UI node-based editors. And we also have this object concept, which encapsulates any and all of the possibilities that you can do with the others and can also use source assets directly. In the node systems, content creators build really complex objects and embed this logic exposing only the values that are necessary to the higher level systems, like the level editor or the script editor. Like, for example, we can have an artist creating a car and expose only a variable that determines the car state, so the car engine state, so be it started or stopped. The artist has the chance to create all of the logic for a started engine, like adding sound and particles and animations inside the object editor. Whereas at the higher level system, the level designers will only set the state of the car. If they want it to be started, they set it to start. Otherwise, just leave it at stop. So at this level, at the higher level system, basically level designers don't have to worry about what's going on under the hood inside the object editor. This is what nodes look like to content creators. So they can start with something simple and work their way up until they can get really complex setups or ingredients. And here you can see the particle, shader, UI, and animation node editors. And you can notice that they, while they have different functionalities, they look very much the same. And this comes with a range of benefits. Consistency is one important benefit. So while each node editor can have a different layout, they all look and feel the same, and most dockables can be reused. For instance, the node search dockable is available for all node editors. Additionally, most of the features that are available in one editor are available in all of them. So variables, compounds, animations, and array support, they benefit everyone working with node editors. And most importantly, it's easy to transition between systems. So if you start working in one node editor and become accustomed to it, switching to another node editor will be smoother. Node systems inherently interact with each other, and and they draw the user to get into other systems. And Liviu can give you a bit more details about how content creators work with these node editors.
Right, so let me introduce you to one of our empowered users. This is Adrian. Adrian is a technical artist. So when he joins a project with Snowdrop and starts learning it, he quickly learns how to create and build simple props that are used to populate our environments. Within a short time frame, that could be maybe weeks if he's ambitious. So within a short time frame of learning and experimenting with the engine, he begins to create more and more complex setups. So again, here we are with something very simple, a simple prop, a traffic cone that only has a mesh and collision. We are starting our way here and working our way up to really complex setups that may include multiple assets, animations, and sound. So it is all about providing a framework where content creators can create logic for their ingredients. We don't use lists because they are very abstract to users. Instead, like Andrea mentioned, we expose atomic parameters and give our users the freedom to play with them and be creative. So these atomic parameters can talk to each other, and content creators can use them to create logic for their ingredients and setups. So this is another example of a node graph for a prototype. And you're going to say, wow, this is really complex. And in fairness, it is. But what you have to remember is that someone has linked all these nodes together with a very clear purpose, even in the case of a prototype. Of course, there is always room for improvement. And because this is a prototype, it's not properly documented. As you can see, there are only 2 comment boxes. And developers really need to comment their work. But the end result is something really meaningful. So this is the node graph for a turret that turns, fires. You can see the barrel starting to glow as it's firing. And what I mean is to get here, it just takes time and experimentation. Learning Snowdrop is like playing on a slide. There is a climb at the beginning while you learn your first step and how things work in the editor, but after that, off you go. You can create, experiment, and have fun. So because our modules are consistent and learning one really translates into learning some other functionalities, you soon have an entire playground to work and experiment with. our users learn the limitations and the possibilities of the technology. They do this both in a practical way, as in what we can and can't do with the technology itself, but also on a theoretical level. So they understand what is logically possible. And as they grow smarter, they learn to make more educated requests to our programmers. So they also learn to break down requests and ask for something very specific that helps them in their work instead of an all-inclusive magical box. And finally, since they design so much of the pipeline, our users have fun and can take pride and ownership in their work. And for us, proud and happy users means awesome content. They don't just sit around and wait for programmers to fix things for them. They contribute and create an awesome tool.
So, so once our users become proficient with the engine, we get to do more and faster iterations and be productive. So how does Snowdrop ensure a fast iteration process? Well, it starts off with being an intuitive editor that is easy to navigate. So this, of course, the what you see is what you get core pillar of Snowdrop. The tools are connected to the game and the results can be seen immediately. So any changes that the content creators make, all they have to do is hit save and they immediately update in the game. This has been absolutely key to developing a lot of our systems, from menus to skills and missions. So not only do we build our systems and see the results right away, but we're also connected to live data. Finally, we need to ensure that all of the changes that are done by our content creators can be easily debugged. When you have data coming from multiple node systems, it can be really easy to get lost. So you need to find a way to identify where this data comes from. So we have a fairly strong dependency tracking tool. Other debugging tools can be developed and can be easily added to the editor itself. And we also have a visual difference tool that is really helpful to see the differences between various revisions of certain node files. So with all that in mind, what is in store for Snowdrop? Well, obviously, Snowdrop is proven tech, and it is constantly improving. Ubisoft has shipped a number of great games with it, but the variety of those games speaks to not just how Snowdrop is mature, but also flexible. Snowdrop has a separate module for virtual reality. It supports next generation consoles and also new technologies like ray tracing. Snowdrop is also used right now to develop new Ubisoft titles, and you might have heard about them because they were recently announced. The development of Snowdrop engine is driven by the games, so it's what the game needs that decides what goes into the engine and what subsystems will be improved or added to. And with Snowdrop, the future of the games is in the hands of the content creators. They can unleash their creativity and build amazing worlds and experiences for the gaming community. So thank you everyone for your attention. Let us know if you have any questions.
Thank you.
We are live with Liviu and Andreea.
Hello, everyone.
Hey, guys.
Hello.
Sorry to keep you waiting. Great listening and very refreshing to have a more technical lecture at Dev.Play. We don't get that many of these. Maybe it's something that will improve in the future. We have a couple of questions for you. So maybe a lot of people are asking. You have a lot of independent developers watching you right now. Why does a company like Ubisoft, for example, choose to develop an internal engine such as Snowdrop and not use Unreal? I mean, what is the decision process behind it? What makes one preferred over the other?
So I'm going to take this question. First of all, developing an internal engine is more advantageous for us because we can better control its features and basically adapt to our game needs. Obviously, Unreal and Unity are very powerful engines, but we don't have that this flexibility of editing their ropes, basically. So generally, yes, we opt for internal tools because they help us better with the development process.
Thanks. Is Snowdrop licensable for developers that are not part of Ubisoft?
Unfortunately, not.
Okay, so
It's only available for
okay,
Ubisoft.
I see. Still very useful to see, to get some insight into how the big companies are doing things. And one last question, no. What would you suggest to someone wanting to join Ubisoft as a game programmer using Snowdrop?
One for you. Again.
Yes. So as a gameplay programmer, it's helpful to test the available commercial engines. So Unity is helpful. Unreal is even more close. It's even closer to Snowdrop because of its blueprints. So any experience with both of these engines should help in developing at first your own game, and then it would be easy to adjust to what Ubisoft needs. So as a first step, if you want to, if you don't have previous experience with building a game, you can try building one with one of the commercial engines, and then you can build up experience at Ubisoft if you're interested in joining us.
Yes, even as a designer or content creator, it's useful to experiment with what's already on the market, because many of the things that are available in commercial editors are also available in Snowdrop in different shapes.
Right. Thank you very much. There are a couple more questions, so maybe you can stick around on Discord and interact with the audience. Thank you, Liviu and Andreea, and enjoy the rest of the event.
Thank you. Have a good Dev.Play.
Thank you for having us.